Imagine drifting through the emptiness of space. Stars scattered like dust across an infinite black canvas. And ahead of you, nothing. A circle of absolute darkness swallowing the light around it. You're falling toward it, and you can't stop. This is what happens when you fall into a black hole. Black holes are the corpses of massive stars. When a star, many times the size of our sun, exhausts its fuel, it collapses under its own gravity. The core crushes inward, past atoms, past neutrons, until all that mass occupies a point smaller than a grain of sand. What remains warps space and time so severely that nothing nearby can escape. As your spacecraft drifts closer, the first thing you'd notice is the light. Stars behind the black hole bend and smear into an arc, a thin, glowing ring called an Einstein ring. Space-time itself is curving around this object, and the light has no choice but to follow. The black hole doesn't look like a hole at all. It looks like a dark sphere framed by fire. There is a boundary around every black hole called the event horizon. It's not a physical wall. There's no surface to crash into. It's simply the point where escape becomes impossible, where the speed needed to leave exceeds the speed of light. Here's the strange part. If you were falling, you might not feel anything as you crossed it. For a supermassive black hole, the kind sitting at the center of a galaxy, the event horizon is so far from the singularity that the gravitational pull at that boundary is gentle, almost peaceful. You'd cross the threshold without fanfare. No alarm, no flash. Just the quiet certainty that you can never go back. But someone watching you from a safe distance would see something entirely different. They'd watch your body slow down, redden and fade, as if the black hole were pressing pause on your existence. To them, you'd never quite cross the line. You'd just freeze and then vanish. This is time dilation. Einstein predicted it. Near an extreme gravitational field, time passes slower. 1 second for you might be an hour for someone far away. A minute might be a year. The closer you get to the singularity, the more dramatic it becomes. In the film Interstellar, astronauts spent hours on a planet near a black hole, and decades passed for everyone else. That isn't fiction. The physics is real. Time, it turns out, is not a constant. It bends, it stretches, and near a black hole, it nearly stops. Now comes the part that earns its name. As you fall deeper, the difference in gravitational pull between your head and your feet grows extreme. If your feet are closer to the singularity, they're pulled harder than your head. This stretches your body, slowly at first, then violently. Your bones, your muscles, every atom pulled into a long, thin strand. Scientists call this spaghettification. It sounds almost playful. It isn't. For a stellar mass black hole, the smaller kind, this would happen before you even reach the event horizon. You'd be torn apart in seconds. For a supermassive black hole, you might survive past the horizon, drifting in free fall, before the tidal forces finally claimed you. Either way, the outcome is the same. At the very center lies the singularity, a point of infinite density, infinite curvature, a place where our equations break down and physics, as we understand it, stops working. No one knows what truly happens there. general relativity says everything collapses to a single point. Quantum mechanics disagrees. Some physicists believe the singularity is a mathematical artifact, a sign that our theory is incomplete, not that infinity is real. And then there are the stranger ideas. Roger Penrose proposed that singularities are always hidden behind event horizons, the cosmic censorship hypothesis. Others suggest black holes might connect to white holes in another region of space-time, spitting out matter the way black holes swallow it. Some theorists wonder if falling into a black hole means emerging in another universe entirely. We don't know. Not yet. Black holes are where the known meets the unknowable. They are real objects, photographed, measured, mapped, and yet they guard the deepest mysteries in physics. What happens at the singularity? Whether information is truly lost? Whether there's something on the other side? The universe keeps its best secrets behind an event horizon. And for now, that's exactly where they'll stay.